Okay, good morning and welcome to Physics in Classroom. This is a teacher's guide and for digital practical sessions. My name is Obonyo Vitalis. Our objective is to give teachers an array of options that they can use in practicals of physics. Secondly, we say that because we know physics is sometimes perceived as a difficult subject, these options will give learners a more practical approach, because sometimes some schools lack apparatus that they can use to present physics experiment. And I'll take you directly to that. For example, sometimes some schools may not have prisms or any other apparatus that they can use. They can come to these animation and interactive appliances that can make them easy to demonstrate what we have in classroom, what we have in the laboratory, and they can easily interact with them from VISCAC open education resource. If students want to learn about issues to do maybe with the angles in a prism, they can even control and move with the light around it. For example, in this case, they can move the torch. Let me try and move it from this point. They can move the torch. They can even move the position of the light. And from there, they can get the angles that maybe they can use to learn and describe the Snell's law or any other law that comes with the light. Learners can still change and see angles of reflection, angles of refraction, and any other part that they want to see on digital, on optics. Other options can be there still. Allow me to give you another option that can be there for learners, for teachers to use when describing these things with learners. Semiconductors can also be another issue that sometimes teachers find difficult to present to learners. And if this can be presented to learners on a 3-dimension, they can see it from 3D or 2D to show the types of semiconductors that we have. From there, they can see the N-type. They can even see what happens when you change the type of semiconductors that they use in classroom. You can also see it in 2-dimension, and they'll still be able to see the semiconductors type that are there. The P-type, if you change the type of semiconductor, they still can see that and see the N-type. What happens? This is a normal silicon semiconductor. What will happen if it's an N-type? They will see that a different impurity has been added that has an extra electron. At least they can be able to see this and even interact with it by changing the type of semiconductors we have. This is an N-type, a P-type, and they see a hole inside that semiconductor. Maybe I can give the last option so that others can be still discussed while in class. All these are there. The issues of transformers, alternators that we all teach in class, Lenz's laws, magnetism, are all alternatives that can be there, and all of them are interactive whenever you deal with them in a class setup. If you want to look at an alternative of, say, magnetism, you can easily look for it from that search button, and you'll see what we have in magnetism. And therefore, you can pick on one. And this is a case of, say, electromagnetism, a very difficult concept where learners have a challenge of understanding how and what happens, because sometimes these gadgets, when you use them, the school magnets may not have enough strength to produce electromagnet in that semiconductor. So a teacher can basically use this and see what will happen if they move the magnet in and out using these controls that are there. So if you move it in and out, you will see the effect it has on the millimeter because current will be able to be produced. So these are a software that can easily interact and make it move in and out. And all the effect can be seen on that. So as we say, all these options can be there for teachers to use rather than just saying and telling these students this thing theoretically. You can try and have them practically, and they interact with this while in class. Otherwise, thank you very much, and may God bless you all.